Okay, let's get things started. Hello, everyone. Hope you are all well. Let's get the show on the road. You guys have your test on Thursday. And I guess I want to address some things on about the final, especially if you weren't around yesterday or heard the comments in the section about 90 minutes long or wherever that is. Okay, so I spoke to Park earlier today to ask about the final. And the direct quote is, you're playing Chinese telephone, so you guys didn't hear it right. What he told me, because now when I saw 90 minutes, I know what you were mentioning. What he told me was, if a student is doing okay, better than average in the class, they should be able to finish the final in 90 minutes. That is his opinion of the final. Like, if you're all right, if you're decent, you'll be done in 90 minutes. The other students, they might struggle and they might take the whole time. But it's definitely for 2 hours and 15 minutes is the standard time for the final. And in his opinion, though, he thinks it was easy enough to the point where a student who is paying attention could do it in 90 minutes. So that's where the 90 minutes came from. It's not the official timing. So the final is, as it would say, as you guys probably know already, it's on Blackboard. It's going to be multiple choice like the sample that I gave you guys. It's going to be, and this was what I wasn't sure about because he said he might add or subtract a couple questions, but right now it's around 25 problems. So that gives you a little bit more than 5 minutes per problem, 5.4 minutes. At 25 minutes, you'll have like 5.4 minutes per problem. He might throw in another one so that it goes down to 5 minutes per problem. But right now you're looking at an average of 25 problems, multiple choice. I think there are around 5 choices, and it'll be a variety of types of multiple choice problems. And I think even some of them might have like none of the above as the answer and all that good stuff. So other than that, I couldn't really get any information out of him. I was trying to finesse some answers. So you think you would ask a question like this? But yeah, we've both been around long enough to the point where none of us can put anything over on the other one. Like, I see what you're trying to do, Jhevon. You're trying to, I can't give your class any advantage, man. But I tried. I'll actually try to hit him up later and see if I can get anything else out of him. Hopefully I can get something else. But that's what I learned. Multiple choice, it's around 25 problems, same 2 hours and 15 minutes. In his opinion, a decent student will be finished in an hour and a half, maybe less. And yeah, that's pretty much what I know. So yeah, my class, you guys are gonna be done in half that, exactly. Yeah, so that is the latest. And which brings us, and again, remember the final exam is on May 21st at 3:30 to 5:45 p.m. Okay, so that brings us to what we're going to be doing today. Yeah, so I'm going to want you to submit on Top Hat your work for the final. I'll open it on the day of the final. You'll see it pop up. So I probably wouldn't even worry about it until after the final. Right, after you do the final, just log into Top Hat and upload your work. Yes. Question?
So Thursday will be our last class, right?
Yes.
So can you have like another review session before like final?
I was gonna say that. I might have another one on Friday. I might do another extra class on Friday.
But can you have it like before the final? Like, since the final is 21st, can you have it on like 20th?
I mean, like the following week, I'm open to it. I'm not against doing that. Okay. So yeah, if I get enough demand, I'm more than willing to do that. Especially when I try to find out more about the final. So that brings us to today. So you guys have a test on Thursday, and I gave you guys a mock test to do. So now the question is, sorry, I got distracted by some of the comments here. So now the question is, what do you guys want to do today? Because in yesterday's class, I actually went through the mock final. I did the full solutions, and I don't know if you guys want to just repeat and do the same thing today for me to go through it with you guys, or we can do something slightly different. I'm open to either option, so it's kind of up to you. I'm assuming that most of you have already tried the practice test too. Yes. Hold on. So you guys actually want to go look at the mock test. Okay, so maybe we can do a hybrid then. Maybe we can talk about some of the mock test, go over the things that people are really kind of feeling they have trouble with, and any of the other normal stuff that you kind of figure out that you guys could do on your own. You can watch yesterday's video. I'll add it to your playlist. Maybe we can do that. Yeah, so let's do that. Yeah, Ash is the only one who's against it. He doesn't want to go through the mock test. So I don't know. What I would definitely say is that if you have not done the mock test, then you definitely shouldn't watch me do the mock test. Anyway, let's actually share a screen here. Let me turn off videos and let's get this thing started. All right, so there you have the usual updates. Let's do some practice problem from the book. So here was my other idea. So I already went through the mock test like completely in yesterday's class. So the video of it is up. It's in the other class playlist, but I could add it to your class playlist. So what I was thinking that we could do is we can do some practice problems that are more towards getting you prepared for the final in the meantime. Meaning we can cover the same topics that I would have covered by going through the mock test, maybe even a little more, but let's do some multiple choice problems. What do you guys think? Like actually give you guys maybe things that, you know, would kind of feel more towards your final. Now, like I said, I don't know specifically what your final is going to look like, but I'm going to pick some problems that I think are reasonable to ask on a multiple choice final, so we can actually just do that. So I looked up some tests, and I could have found more, but I looked up some tests. So what I can do is just throw some multiple choice problems at you, throw some true or false problems at you, make sure you guys have the concepts down, make sure you kind of know how to, at the very least, do a process of elimination kind of thing. If you want to actually see solutions to the mock test too, as I mentioned, I already did it in a YouTube video yesterday, so you guys can go back. And you can even if you don't want to watch the video, you can actually pull up the PDF and just quickly just scan through to the problem that you wanted to find out about. Yeah. So one thing is I just don't want it to be in the situation. Yeah, I would say still all the past finals. I will give you a final review that I think is still good for you guys to go through. But I'll still do a final review. So let me just leave it at that. At the moment, I don't want you to look at the past finals just in case I want to use problems from that set. But yeah, so let's actually go through with that. Let's actually, so the mock test, I had the questions copied in here, but let's actually just do a whole new thing.
Professor, I have like a
Yes.
specific question.
Yes.
It's about the finding the length of the curve.
Yes, that is a formula. It's an integral formula.
Yeah, but I have like a specific question with a variable in it, and if you don't mind, can you like just like help me do it?
Oh, what is the question?
So it's like it's saying that x is equal to the cosine squared t.
Question, special request. X is equal to cosine squared t.
Y is equal to sine squared t.
Yeah.
And then the interval is 0 is less than or equal to t, greater than or equal to pi over 2.
I mean, you mean less than or equal to pi over 2? Yeah.
Yeah. Yes.
And you just want to find the length?
Yeah, you just said to find the length of the curve.
Yeah, so remember the length of the curve, there's a formula for that. It's the integral from a to b of the square root of x prime squared plus y prime squared dt. So that's going to be the integral from 0 to pi over 2 of the square root of, you're going to take x prime, which is 2 cosine t times minus sine t, and you're going to square that, and y prime is going to be 2 sine t cosine t, and you're going to square that. Right, so this is going to be now what you can notice in on the inside is that there's a half angle formula or double angle formula, however you want to think about it. But on the inside, it's minus sine 2t. And on the inside here, it's sine 2t. So notice that you have under the radical 2 sine 2t squared. So then that just becomes radical 2 times integral from 0 to pi over 2 of the absolute value of sine 2t. But of course, on that interval, sine 2t is positive, so that just becomes radical 2 integral from 0 to pi over 2.
Wait, how did you get 2 again? From
Because I added these two.
But isn't it on the one side is sine is negative and on the other side sine is
It's
positive?
a squared. It's being squared.
Okay.
The negative dies because of the square.
Oh, okay.
Right. So it's actually two of the same things. Right. You can ignore the negative sign here because it's squared.
Oh, okay. I see.
So yeah, now you just do that, and so you integrate that. You're going to get minus 1/2 cosine 2t. And then, of course, you can finish that. But the important thing is, of course, you need to know this formula. That's how you find the length of a curve. All right. Now, let's actually throw in some examples. So I have a bunch of tests. Let's look at one. Maybe we can warm up with some true and false, then kind of go into some more multiple choice that has more options. Okay, so warm up. Boom, here are some questions. All right, guys, take it away. R comma theta and minus R comma theta plus pi. These are polar coordinates of the same point. True or false? Go. True, according to Devin. What's your reasoning? That is true. Why is that? Because if you have r and theta, then minus r is the guy all the way back here, and then you just take pi plus the theta to get that, and it flips it back. Now, if the r was positive, this is not true, but they switched it with a negative r, which is why it's true. So that's actually true. What about this? This graph, the graph of the polar equation r cosine theta equals 5 is a straight line. True or false? True. What is the straight line specifically? It's x equals 5, right? So it's actually the line x equals 5. It's a vertical line. The graph of the polar equation r equals cosine theta is a circle. True or false? Think false? Well, let's see. So let's look at 3. If I look at r equals cosine theta, here's a trick that we can do. Multiply both sides by r. R squared is x squared plus y squared. R cosine theta is actually x. So this is x squared minus x plus y squared equals 0. This is x minus a half squared plus y squared equals a quarter. That's a circle. True. All right. So this is the sort of thing I'm afraid of with the multiple choice, because I know you guys know the equations, but I want to make sure that you can know all the information but still can't manipulate it in a true or false or a multiple choice context. I want to make sure you guys are good at that. Problem 4. Well, never mind that. I didn't actually teach you guys about what this is, so screw that one. The graph in the xy plane, x squared minus y squared equals 0. Is that a hyperbola? True or false? Right, guys, taking so long. This is just the warm-up. It's false. X squared minus y squared equals 16. Is that a hyperbola? This is true. In fact, you would actually divide both sides by 16 first. And this just means in the box in the middle of the hyperbola, you move 4 units in the x direction, 4 units either way in the y direction. That's actually true. Okay, P, Q, and R are 3 points in space. Then PQ minus RQ is equal to PR. Right, so you have 3 points. So we're looking here at problem 7. 3 points P, Q, and R. So if you look at PQ and you look at RQ, if you take this minus that, what do you think? So now they're asking about this vector here, PR. Oh, wait. Right, it's RQ. So this goes that way. So if I take this one minus that one, yes, that's true. So be careful. Remember, the second guy is the final point. P equals this, Q equals that. Is QP equals this? What is this vector here? This is actually the vector PQ, right? So this is false. The unit vector opposite in direction to the vector blah is blah. True or false? So in the opposite direction means you take the negative of this. That's completely opposite direction. Then you would find the unit vector by dividing by its magnitude, right? And the magnitude of this vector is what? It's 3. It's the square root of 2 squared plus 1 squared plus 2 squared. So it's the square root of 9, which is 3. So I divide by 3, that gives me a unit vector, and then I change the signs. I multiply through by a negative. So this is actually true. A vector parallel to this line is that. Okay, so what is the vector that you're going to look at that's parallel to this line? What vector would you come to mind first? 2, 1, 1, right? So now you want to see, is this guy actually parallel to that, right? Is this a scalar multiple of that? And the answer would be no, because I would have to multiply the first coordinate by minus a half to get the second coordinate, the first coordinate here. But if I multiply this by minus a half, I don't get the other one. So this is false. Okay. Are we warmed up yet? It's tricky. And this is just true or false. There are only 2 options, yes or no. You want to do some more true or false, or you want to try maybe let's quickly run through these here. So here is another 10. But it gets you guys to think, right? Probably in a different way than you would be thinking if you were actually writing out a long form answer, which is the point. And then that was the next 10, and then and here are the final 11. So this document I was looking at had 31 problems. Okay. Normal vector to this plane is that. True or false? What is the normal vector to this plane? The obvious one. 1 minus 2, 1. Right. Now you'll notice that this guy here is actually negative 2 times that. This is, and if you multiply this by negative 2, you get that one. So this is true. Is this true? I plus j plus k cross j is equal to I plus j. That's false, right? Because that would mean that this guy is equal to 0, which we know it's not. If u and v are vectors in 3 space, then u cross v is equal to v cross u. True or false? False. What is u cross v equal to? If I switch the order of the cross product, what happens? Right, you get the negative. These guys are vectors in 3 space. The magnitude of u cross v is equal to the magnitude of v cross u. True or false? That's true. If these are vector in 3 space, then this dot with the cross product of u and v is 0. True. How do you know it's true? Right, u cross v is orthogonal to v, and we know that if two vectors are orthogonal, then the dot product is 0. These are vectors in 3 space, then this cross this is equals, that should be equals, this cross u. True with a question mark. That's actually true. When you switch the order of the cross product, you get the negative, and remember, you can factor constants out. So those were applying two properties. I cross k is j. False. I cross k is minus j. You can remember from that I, j, k. You can remember from that circle that goes clockwise. I cross j is k, k cross I is j, j cross k is I. But here, if you do I cross k, you move the opposite direction, you get negative. It's negative j. Oh, for 16, we had a property. So, I mean, for 16, we had a property that said if you have a constant times one vector cross another vector, you can move that constant around. You can attach it to either vector, you can factor it out in front. And all that good stuff. So here, if I have the 3u cross 2v, I can move the 2 out in front to get 6u cross v. Then if I switch the order, I get the negative 6v cross u. If the vector y is a scalar multiple of the vector x, then the cross product is the 0 vector. True or false? True. We know that if two vectors are parallel, the cross product is the 0 vector. And one vector being a scalar multiple of the other means they're parallel. And we know that because the magnitude of the cross product is the magnitude of the product of the magnitude of the vectors times sine of theta. If x and y are vectors in 3 space, then x cross y plus y cross x is equal to 0. True or false? True. Cross product of two unit vectors is another unit vector. True or false? This is false. Yeah, think about it. Here's the problem. You guys are thinking of the basis vectors. You're thinking just because if I cross I cross J or all of that stuff, I would always get, remember, so example, remember, I cross I is what? That's 0, which is not a unit vector. Right? If you take two parallel unit vectors, the cross product is going to be 0, the 0 vector, which is not a unit vector. Right? So the trick here is parallel. And I'm not all too sure if they're not parallel, it's always going to work out. We know that if the two unit vectors are orthogonal, then the cross product is actually a unit vector. But we don't know in general. I mean, it's not hard to figure out, but I don't know that off the top of my head. Cross product of two perpendicular unit vectors is a unit vector. Right, so here they threw in the extra phrase. Right, now that one is true. And that is why I believe a lot of you thought the last one was true. Now that is actually important. Right, you weren't missing. And so that's the kind of thing that you definitely have to watch out for on the final that's coming up. Because they'll take a statement where it has a lot of truth to it, but the devil is in the details, right? If it's not completely correct from a mathematical perspective, it's a false statement. If you can't say that it's true in all contexts, then forget it. Set of points. This is a circle. True or false? This is false. That's a cylinder. That's a circle. The difference, of course, is this is in R3 and that's in R2. The point this lies on this surface. I mean, that's kind of silly. You just have to plug in the coordinates and see if it's true. So if you plug this in, this should give you 4 minus 3 minus 9. Okay, so false. This is an elliptic paraboloid. False. Which you should know the equation of a paraboloid. For a paraboloid, you need one of the variables to not be squares, right? And the signs of the other two have to agree. The two lines intersect at one point. That's I mean, that's kind of annoying to do. But of course, you know, you'll just actually find, unless there's an easy thing here. I mean, they're not parallel, so you just have to check whether or not they intersect. Not parallel. So check for intersection. I don't want to waste time working through that. Still in the warm-up. This line and the plane intersects at one point. Again, I probably don't want to do that. One way you can check is to see, just do the dot product. 1 comma minus 3 comma 2. And dot that with the normal. This is going to be 1 minus 3 plus 2. That gives you 0, which means this is parallel to the plane. So I know it's parallel to the plane. So now you just want to check for a point of intersection. So check for intersection. I don't want to waste time going through the calculations here because these are true or false. I want to get to the questions with more things. So I know this is actually parallel to the plane. Hold on. No, parallel just means parallel means if it intersects the plane, it intersects at all points along the line. And if it doesn't intersect the plane, then it will perhaps never intersect the plane. So that's how you'd have to think about it. So knowing it's parallel means I need to try to find an intersection point. If there's one intersection point, then all points would intersect. All points along the line. If there is 0 intersection points, then it will never intersect. So that's what I would check. If two lines in 3 space don't intersect each other, they must be parallel. I told you guys that is false. That's actually true in 2 space. It's not true in 3 space. P1 and P2 are planes with normal vectors this and that respectively. If N1 and N2 are not parallel, then the intersection of this is line with N1 and N2 as a direction vector. Yes. We actually solved the problem like that. I believe on your mock, we actually used, that's the strategy to solve one of the problems on the mock exam. We took the cross product to find the line of intersection. Okay, so if U cross V is 0, then U equals 0 or V equals 0. We know that's false, and again, can use the same example. I cross I is 0, but neither of those are 0. If U dot V equals 0 and U cross V equals 0, then this is true. Like, do both of these have to happen? So this means that they are orthogonal. And this means they are parallel at the same time. What is the only thing that's orthogonal to something and at the same time parallel to that thing? The 0 vector. So yeah, one of those guys have to be the 0 vector. So those are some true false. Okay, gets you thinking, huh? You guys can actually work on these. I don't want to spend too much time on true or false, but you guys can work on those to see if you can verify the answer. Let's see, let's try to find something else. Here we go from another document. Oh, I'll eventually get to limits. Let's go. Do 9 and 10. And I have some more samples here, but they actually indicate the answer. I don't want that. B is the answer for what? There are two, I posted two problems here. So tell me the answer for both. Okay, keep going. I'm copying and pasting some other things here. See, no, we didn't cover that. We didn't cover that. We didn't cover that. Okay, so that's all I'm taking from this document. I believe I saw some here with limits, but we'll get to those soon. Okay, so 9. An integral of the form that cannot have a finite value, may or may not have a finite value, always finite value. Well, someone said B, and that is correct. In fact, for those of you who are going into, well, not only those of you, but more specifically those of you going into engineering, when you take a class called differential equations, you're going to learn about something called a Laplace transform, and it has that form. And if that could never give you a finite value, then engineering would be in trouble. What is this improper integral? So your intuition should tell you that it's not divergent. So now it's just a matter of actually computing it. So that would be e to the minus 3t over minus 3 between 1 and infinity. Of course, if you plug in infinity, you get 0. Minus you plug in 1, you get a third. A third e to the minus 3. So that looks like C. I think that was a typo. I think the T should have been an X based on the answers. I think this should be an X. However, if and I guess this is something you can look out for, if it were a T, so you would have like the integral from 1 to infinity of e to the minus 3t, and then someone asks you about dx, what would that actually be? Yeah, it would just diverge. Right, because then this integral here would just be a constant times x. And then you plug in infinity for the x. That's going to be infinity minus the constant. Right, so that would be divergent. But I think that was a typo. As
Wait,
typed in,
so which one is correct? Is it diverge or is it the answer you wrote?
I fixed the typo. This was a typo. So if I put what was intended with an X, then it would converge. If they actually meant to type a T, which they didn't, then it would diverge. So, yeah. What about this? This point how many units above the XY plane? It's 11, just the Z coordinate. The graph of this function is set equal to a constant. So we have some function, Z equals f of xy. If y is set equal to a constant, we will obtain a curve resulting from a slice parallel to the which plane? Setting y equal to a constant means you're in a plane that's parallel to which one of these? Right, xz. Match the graph with one of the equations below. What is this guy? Or maybe let's practice our process of elimination here. Tell me what it's not. D, how do you know it's not D? D is, what is D? Tell me what D is. It's a plane. So that's not a plane, it has a pointy tip. This Z equals x squared plus y squared, what is that? No, that's a paraboloid. This guy is an upside down cone. So that's actually the guy you want. B, we didn't really see a graph that looks like this, but this is 1 over x squared plus y squared. Z equals that. Which tells you, but one thing you do know is you know that it blows up close to the origin. So you'd expect if you were close to the origin for that guy, it'll start shooting super far up from either direction. So it's not going to be that guy. The graph of this equation has an x-intercept of what? Right, 900. Find the second partial derivative with respect to y if your function is that. Okay, so we have minus x over y squared. Let's actually see. So take the partial with respect to y, then that would be x over y plus e to the x. And take the partial with respect to y again, minus x over y squared, and the e to the x goes away. Right. Let's see here. Someone was asking for limit problems. Let's see. I saw a limit
Professor?
problem. Yes.
One of our classmates just asked me that do you have to submit our for the final, do you have to submit our multiple choice on top hat?
No, the multiple choice is in Blackboard. You have to submit your work on Top Hat.
So we have to do it on the piece of paper and then we have to submit it?
Yeah, to do the test, you're going to be writing stuff out on paper,
Oh, okay.
right? So just save your scrap, essentially. So write down whatever reasoning that made you choose the choice you picked, and you're going to um, send that to me at the end.
Oh, what if I guess?
Like total randomly? You must have a reason for why you guessed something. So
Should
like,
I
for
just write
example, in this,
so should I just write when I guess should I just write got pass?
no, you should say something like, tell me how you eliminated the guess. Like, tell me how you eliminated some of the choices and guessed from the other ones. So for example, for this one here, like if you eliminated these two and then randomly guessed between A and B, then that gives me something to grade. You know what I mean? So if someone just like, I guess B is the answer with no result, with no explanation, versus someone tells me, well, I know D is a plane and I know C is a paraboloid, so it's not one of those two. I'm not sure if it's A or B, so I guess B. That student would get more credit than the first student. Even though both of you guys got it wrong, one clearly put more thought into it. One clearly showed that they had more knowledge and they were actually reasoning through it, thinking critically. So the student who just guesses an answer with no explanation, I have nothing to grade. Like they just lose all the credit at that point. I won't be able to say, well, they were kind of on the right track, but they messed up here. Like I won't have that. I won't be able to say that. So yeah, that was fun. Let's see, did I find I know I saw some limit problems, but in the meantime, true on this, it would involve a limit. Is that guy continuous at the origin? Well, the limit, so sine of 0 over 0 is not defined, but if you take the limit as something is approaching 0, so this means if I take the limit as my x, y, z is approaching the origin of my function, that answer is going to be 1, and that is equal to the value of the function at the origin. So this means true, it is continuous at the origin because the limit is equal to the value of the function.
Professor, I have one question about the limit.
Yes.
So it's limit as x, y goes to 0, 0. The expression is x squared, y squared.
Oh, you're giving me a question?
Yeah.
Limit as x, y approaches 0, 0.
It's x squared, y squared, sine y over x to the fourth plus y to the fourth.
Okay.
And he's asked like if to show if the limit exists or not.
Okay. Let's throw that out to the class. What do we do, people?
I mean, I did it so far and I found that the limit exists, but then I started using the squeeze theorem, and then that's where I got like a little confused.
How did you show that the limit exists?
So first I said I used the x-axis path, which is y equal to 0.
Okay, so you went along y equals 0.
Mm-hmm.
And this would mean that the limit would be, well, to be 0 right away. Then?
And then I used I used 3 of the paths. So I then next I use y-axis where x is equal to 0. And I got
Right, yeah.
equal to
That's
0.
gonna be obviously the same thing. So
And then for the third one I got 0. So then I started using
what is the third one?
the x equal to y.
So you did y equals x.
I mean, yeah.
And so your limit is going to look like, say, x to the fourth sine x over 2x to the fourth. These guys would cancel. And so, yeah, that's going to give you a 0 again once you actually evaluate the sine function. Right? You would get sine of x over 2, and you plug in x equals 0, so it goes to 0. So now you're suspicious it's going to go to 0. Okay, so now you think the limit is 0, so you're going to go x squared y squared sine y over x to the fourth plus y to the fourth and minus 0. So this is x squared y squared sine y over x to the fourth plus y to the fourth. All right, so right. So Ash is like, well, since I know that the sine of y in absolute values is less than or equal to 1, we can compare this guy too. Well, that's less than or equal to. If I replace the numerator in the sign in the numerator with 1, I would get that. Now, can I figure out a way to get that to be a function that approaches 0 for sure? What happens now? Okay, but if you make x equals y, you would end up with a half, which is no good. Remember, you need to actually end up with 0. So ending up with a half is not good. Other ideas? Give the denominator more power. What do you mean? So going down that road is a problem. I'll tell you guys right now, this is one of those weird examples. It actually doesn't fit the mold that we've been looking at so far. So it actually does not exist. Yes, getting 0 from 2 path is not a guarantee. It is just, it is a statistical thing. Remember, any test where you do a finite number of paths, it's not going to give you the actual answer. This one actually does not exist. The power in the denominator is actually too big. I don't know. Maybe this one does exist. Anyway, let's try a different approach. Let's see. Let's go with the other strategy, because this isn't going to help us. So what was another strategy that we learned? What was the other guys that we looked at? Because we looked at a bunch of strategies, right? X equals y squared. I don't think that would help. I think that would still give you 0. Let's do polar. So let's look at this limit. See if this can give us a nice answer. So it's x squared y squared sine y. So it's r squared cosine squared theta r squared sine squared theta sine of y is r sine theta over r to the 4th sine. I put this the other way around. This is the the y to the fourth, plus r to the fourth, cosine to the fourth. This is going to be equal to the limit as r approaches 0. That is going to simplify into the r to the fourths would cancel. So this is cosine squared theta, sine squared theta, sine of r sine theta over sine to the fourth theta plus cosine to the fourth theta. And now you'd realize that the inside here is approaching 0. So then this whole thing here approaches 0. So that exists and it equals 0.
Professor?
It's hard to go by the g function though. Like I can't think of a function
But
g that is going to work.
can you take a limit for the g though? Like if I set y equal to 0 and then solve it, I actually get 0.
No, because now you're just looking at one path. The moment you say set y equals 0, you have now restricted yourself to a path. It means now you're only looking at things in the xz plane, which is not good enough. You need to do something in such a way that you can determine that from all paths, your limits are going to be, to give you the same answer. So yeah, it's hard to get the squeeze theorem to work here. And I don't really want to spend any more time thinking about it, but the polar situation seems to work. Now, how I would definitely determine that the limit does not exist is if I get to a situation here where there are no r's and the answer has a function of theta in it, then I could conclude that it does not exist. So let's, yeah. Okay, hold on. Let's see. You guys want to do some more limits or continue with the thing? I mean, how has limits been going? Like when you guys are practicing? Because the few students who actually stayed on yesterday and I went through the mock test with them, the limit problems wasn't the major problems. Like a lot of people, not to spoil anything, had problems with question 4 and question 5 on the mock test. I believe the limit problems was question 6. Yeah, so polar is it's another option. That's why I showed you guys. Sometimes it can just help you get to something a little bit more definite. Let's look at so you want to review partial derivatives with differentials? What do you mean with differentials? You mean like the implicit differentiation situation or just the Leibniz notation? All right. Let's do some problemas. Okay, let me look up some partial derivatives. Here's another thing that I think. Here's some other things you guys can look up. Paul's Notes is a great resource, but there are some practice problems. They're not multiple choice, but it might help. Also, here, there are some assessment tests here that I think you guys could get. And we can do more reviews like the multiple choice later in the week, but for now, we can go back and kind of do okay, now let's look up some implicit differentiation. So this was section 14.3. Let me try to find some sort of, at least I'm not sure how much implicit differentiation is going to go. Okay, here's one. Find partial of z, partial of x at 1, 1, 1 if xy plus z cubed x minus 2yz equals 0. And the question said, assume z is some function of x and y. Okay, so start there. What do we do here? Are you guys working on it? Or are you? What is the partial with respect to x? What did you get for the answer? Do you guys have the answer yet? Okay, let's do this. What would I do? Well, the partial with respect to z of x, I would just think of this as minus fx minus fz, where this guy here is your big F. So that's going to be minus partial with respect to x everywhere. You would get y plus z cubed. And then partial with respect to z everywhere, 3z squared x minus 2y. So that's going to be your guy. And then at 1, 1, 1, partial of z with respect to x evaluated at 1, 1, 1 is equal to minus 1 plus 1 over 3 minus 2. So minus 2 would be the answer. Did anyone get minus 2? Okay, good. So this was actually problem 75 from inside your textbook. Now you could do it the long way. There's no virtue in doing it though. So, I mean, especially if it's a multiple choice problem, like this is going to be very useful. So F is a level curve. So you bring everything to one side. Can you explain that part in the green? Well, in short, no. But in principle, I would say yeah. So what you want to realize is note what's going to happen. The real explanation is that this is an application of the chain rule, the multivariable chain rule. So if I don't tell you the multivariable chain rule, it's going to be hard or harder. Let's see, can I give you a simple explanation without going through the multivariable chain rule? But the idea is here, if you have xy plus z cubed x, the idea is you're taking the partial with respect to x of everything. So here you're taking the partial with respect to x of the xy. You're taking the partial with respect to x of the z cubed x. You're taking the partial with respect to x of the 2yz, and that's going to give you 0. Now these guys here are going to give you a partial z, partial x as a part of it. It's going to give you some blah plus the partial z, partial x. This is also going to give you some blah plus the partial z, partial x. This guy is just going to give you some other blah with no partials attached to it. So what you're going to realize is the guys with the z's in them in the first place, they're the guys who you attach these things to in the first place. And then you move everything over. So if this blah here, you move over there, you're going to get a negative blah. And then you're just going to end up dividing by the two things that were attached to the z's in the first place. And so you can kind of think of that here. So I take everyone with respect to x, except in the case where they had z's in them, they had to stay on one side and I had to divide them out. So from an algebraic standpoint, that's how you'd think about it. But it's more of an application of the chain rule. And so you can actually do this all the time. So let me show you guys the trick, especially if it's a multiple choice. Let's say you have this x squared y plus xyz minus 2xy cubed equals, I don't know, ln of x. And I can ask you to do the following. Find partial y with respect to x, find partial x with respect to z, find partial, I don't know, x with respect to y. I can ask you to find a bunch of things. Now, these would all involve finding implicit differentiation. So how I would do them is the following. So step one, bring everyone to one side. And call the non-zero side big F of x, y, z. Right, so if I see that, my first step is going to look like, well, x squared y plus xyz minus 2xy cubed minus ln of x equals 0. And I'm going to look at this guy here as my big F. And now, anytime you want to ask me one of these guys, I actually know how to deal with it. Then 2 apply the formula that I gave you. So when you look at dy dx, partial y, partial x, right? That is going to be equal to a negative, and you're going to have f. You actually switch the letters, right? So the y part comes down to the bottom, and then the x part goes up to the top. And so if I were to ask you, what is the partial of x with respect to y? Well, that's going to be minus f sub y over f sub x. Or if I were to ask you, what is partial of z with respect to x? Well, that's minus f sub x over f sub z, and so on and so forth. All right, that's always what it's going to end up being. And the more general theoretical answer to this is chain rule, which has a couple variations in multivariable calculus. But you can kind of just see by how you would actually go about doing it the long way, why this would have to actually be the case. But yeah, so doing implicit differentiation comes down to actually doing that. So you can actually think of implicit differentiation in these two steps. And by the way, this would actually have worked in Calc 1. It's just that at that point, you didn't know what a partial derivative is, so it would kind of really be cheating for them to give you this formula, because, you know, then they'd have to explain to you what a partial derivative is, and oh, you have to now imagine that all the variables are constant. It's just too much for a Calc 1 student to process. But once you're now have processed what a partial derivative is, implicit differentiation should be relatively easy. So if I look at this one now, copy, I can take a bunch of different derivatives in a really quick, efficient, effective way. So if someone were to ask me, well, what is the partial of x with respect to y? Well, that's going to be minus f sub y over f sub x. That's going to be, now I just go through here and differentiate everyone with respect to y. So that's going to be x squared plus xz minus 6xy squared. Then divide that by, take the partial of everyone with respect to x. 2xy plus yz minus 2y cubed minus 1 over x. And that's the answer. Or you might say, what is the partial of z with respect to y? Well, that's just minus partial y over partial z. So I'm just going to go through and I'm going to take the derivative of everyone with respect to y. Then divide that by taking the derivative of everyone with respect to z. So that's xy, and that's it. That's just xy. That's the answer. So we're really kind of jumping the gun here, but hopefully that's something you're going to learn about in the next class. But at this point, you already know about partial derivatives. I don't think it's too much of a stretch to just tell you, hey, this is a formula out there. It works all the time. It's super easy to apply. You will get the theoretical underpinnings of it in the beginning of the next class. So I believe in 213, I think this is going to be the first thing that you actually look at. So 14.4 in your textbook is the chain rule. And in that section, you're going to learn this formula that I just gave you, and you're also going to learn some other formulas. And that just comes with dealing with how do you differentiate a multivariable function when there's an inside function and an outside function, and how do you apply implicit differentiation in that case. And yeah, and you guys might have recalled back in Calc 1, implicit differentiation really was just an application of the chain rule anyway. So once you learn about the multivariable chain rule, implicit differentiation just becomes an easy, like, you know, side benefit kind of thing. Like now, oh, we know the chain rule, so now we just know how to do implicit differentiation easy. That's all we have. Yeah. So that's implicit differentiation. You can do it by that formula. I mean, you could have also done it the long way, but I'm not sure why you would want to do that. The formula, this is for implicit differentiation specifically. So that's why I titled it implicit differentiation. I mean, a partial derivative is a whole other thing. Remember, partial derivative just means you consider one variable a variable at a time. All other letters are constants. And you can just go through and apply your derivative rules there. Implicit differentiation comes into play when one of your other variables are not considered a constant, but they're considered to be a function of one of the variables. So here, so here we have our guy, but we're specifically thinking of z as a function of x and y. So even though I see z here, I cannot think of it as a constant because really there are x's inside of it that I don't really know what they're doing, right? So implicit differentiation comes into play when one of your variables has an inside function that might correspond to the variable that you want to differentiate with respect to. So you can't just go through and just pretend everyone is a constant except that guy, because some of those guys have functions inside of them. They're disguised. So that's how implicit differentiation comes into play. It's when one of your functions are considered to be like some inside function. No, if z is a function of the guy you're differentiating with respect to, that's what makes it in it. If for example, I knew that z was a function of y and only y, then I would just find partial derivatives as normal. There's no implicit there. Implicit comes into play when there's an inside function of the variable under consideration. So it's like when you see a z, it's not really a z. It's really some function that has x's in it. And since I'm differentiating with respect to x, I can't think of that z as a constant as I would normally do because there are x's inside somewhere. So that's kind of how you're thinking of it. So the implicit differentiation case is when one of your variables is a dependent variable. In partial derivatives, you consider they're all independent variables and one has nothing to do with the other. but then you just want to take the partial derivatives with respect to one of them. That's just regular partial derivatives. But once one of them depends, you have a dependent variable in the mix, now you're into implicit differentiation territory. Yeah. What if I were to ask you a question like this? Find the distance from 1 to 1 to the plane go. You have to use a scalar projection. How would you get it to apply? Scalar projection of what to what? Devin, did you leave? So yes, it is a scalar projection, but from what to what? Of a vector from the point to the plane and the normal to the plane. Yeah, so that's how we did it. So we had a plane. Here's the point. You created a vector, called it B, and then there's the normal vector to the plane, N. And you want to project the magnitude of B onto N, and that's going to give you this guy. So the distance here is going to be the scalar projection of B onto N. And remember, the scalar projection is in terms of dot products, not cross products. So that's going to be N dot B divided by N with absolute values around it. So that's actually a dot product. So now the question is, how would we find the B? How would you find the B here? You can use an intercept of the plane, one of the axes, second point. Okay, so tell me a point. So you would find a point. So this here is the point 1, 2, 1. We can find a point in the plane, and you can pick any point that fits the equation of the plane. So heck, 1, 0, 0. Why not make our lives easy? And so I can just take, and then I can do that. Then I can find the vector of that. So the normal vector is 1, 1, 1. B is going to be final minus initial, 1 minus 1, 2 minus 0, 1 minus 0. And then I would divide that by the magnitude of the normal vector, 1 plus 1 plus 1. So that's going to be, on the top, that's going to be 3 over radical 3. And that's the distance, 3 over radical 3. Okay, what if I ask you this instead? What is the distance? Find the distance from 1, 2, 1 to the line. So that was distance from a point to a plane. Let's talk about distance from a point to a line. So let's say it's x is equal to 2 minus t, y is equal to minus 1 minus t, and then z is equal to 3 plus t. How would we do that one? Okay, so what's your PS here? Nicholas remembered that formula and he's like, well, it didn't work last time. It's probably going to be this one. It's like, it's going to be right eventually. I have this formula memorized. It's got to be useful for something. So yeah, this one is actually a cross product. So you have a point and you have a line. And basically here, if you can find a point on this, connecting to that point. So again, that's my D. So this, my point over here is 1, 2, 1. Now, of course, this is going to be the direction vector for the line. So there's a V here. Right, so that's the direction vector for the line. Right, which we know here is the minus 1, 1. Now, what you want to do is measure this distance here. However, if you actually put like a theta here, then you're going to realize that this is going to be the magnitude of B sine theta, which means this is going to be, so your D is going to be the magnitude of B sine theta. This is going to be A, B sine theta divided by, or let's do V, B sine theta over the magnitude of B. And so that's going to be the magnitude of the cross product, V cross B, divided by the magnitude of V. And so now it's, you do the same thing. You try to find, take a random point on the line. And again, you can pick any point. So pick the easiest one. Plug in t equals 0, you get a point here. So that's going to be 2, minus 1, 3. And so from this, you can get the fact that your B is going to be 1 minus 2, 2 minus a minus 1, 1 minus 3 is that. And then you also have that your V is going to be minus 1, minus 1, 1. And so now what you're going to do, this is going to be equal to the magnitude of course, I, J, K, minus 1, 3, minus 2, minus 1, 1, over the square root of 3. And so that is going to be the magnitude of 3 minus 2, minus 1 minus 2 comma, -1, no, +1 plus 3. So that's going to be the square root of 1 plus 9 plus 16 over the square root of 3. And so that's radical 26 over 3. Yep. V is the direction vector of the line. -1, -1, 1. It's the coefficients of the t's on the line. Anyway, we're going to wrap up there. That was a good review session. We will actually continue next time. So I don't know. Yeah, I don't know. Maybe Friday we do something. Maybe we actually just wait until next week. I have you guys just actually continue studying, going over everything. And so by next week, you'll know what you'd want to ask me, if anything. But yeah, we are going to stop there. So as always, take care, guys. Hopefully that review was helpful. Go through the mock exam if you haven't yet. And once you do that, you can check the video. I'm going to put it in the playlist for RS2 as well. But I already did the video yesterday for the GH section, and we worked through the entire mock exam. But do not watch the video if you have not worked through the mock exam. You're shooting yourself in the foot if you do that. Watching Jhevon do problems and doing problems yourself, they're two very different things, okay? So make sure you actually try it and you can get through everything. Anyway, I have another class in a few minutes, so I'm going to let you guys go. I will see you guys in the next one. So, ciao.